בוקר טוב לכולם, אני ליאור צברי ואני מחברת Databricks, ואנחנו מאוד שמחים על ההזדמנות לפתוח את האירוע המרשים הזה לשנת 2023 של AI and Data Summit. קצת על עצמי ככה, אני למעלה מ-20 שנה בעולמות של הטכנולוגיה, ב10 שנים האחרונות, זכיתי ככה ליהנות מהרבה מאוד פעילות בעולמות הדאטה. יצא לי לעבוד עם כלים כמו ורטיקה וקלאודרה, לנהל את הפעילות של החברות האלו בארץ ולהרים את הפעילות הזאת, ולראות איך באמת העולם הזה מתפתח בעולמות של הדאטה, בעולמות של הדאטה סיינס, דאטה ווירהאוס. הצטרפתי לפני משהו כמו 3 חודשים לדאטאבריקס, לחברה באמת שמובילה את העולמות האלו בעולמות של Data Science ו-Data Warehouse. מי שהצטרף אלינו עוד מהצוות האירופאי היום זה פליקס, והוא ככה יעשה drill down יותר לעומק, ולאפשר לכם להבין איך אתם תוכלו לתת ערך לארגון שלכם. פליקס, please, next slide. אני רוצה לתת לכם ככה קצת מידע על חברת Databricks. החברה הוקמה לפני משהו כמו 9 שנים, עם באמת איזשהו חזון של לתת מענה לארגונים בתעשייה בתחומי מידע תחת תשתית אחת, בלי צורך לשכפל את המידע או להסב אותו לאיזשהו פורמט שהוא פרופרייטרי, כמו שחלק מהפתרונות בשוק היום מציעים, והכל תחת קורת גג אחת. אנחנו שותפים של 3 העננים הגדולים, אז'ור, AWS וגוגל, ויש לנו למעלה מ7,000 לקוחות בעולם כבר, שצורכים ונהנים מהתשתית שלנו. אנחנו, עוד איזשהו אלמנט מעניין, אנחנו כל שנה מקבלים אישור ככה מאנליסטים מובילים בשוק כמו גרטנר, שמכירים בנו כמובילים בעולמות של ניהול בסיסי הנתונים, וגם בעולמות הדאטה סיינס. החברה מבססת את הפתרונות שלה על פתרונות של אופן סורס, מאוד מאמינה בגישה הפתוחה, ואפשר לראות את זה קורה במספר פרויקטים הגדול שאנחנו מובילים בתעשייה, וחלק משמעותי מהם הוא בעצם חלק מהתשתית שלנו, פרויקטים כמו דלטה לייק, אפאצ'י ספארק, ML Flow, ויש עוד כל מיני פרויקטים, גם פרויקטים קיימים וגם פרויקטים שבדרך החברה כל הזמן מתפתחת בכיוונים האלו, מתוך באמת ההבנה הזאת שקהילה שנוצרת סביב פרויקטים של קוד פתוח, היא חזקה ומשמעותית יותר מכל פתרון פרופרייטרי שחברה יכולה לפתח בעצמה, באמצעות הארגון הפיתוח שיש לה. Next slide, פיליקס. חברות שככה אנחנו רואים איך חברות התפתחו בעולם בשנים האחרונות, מתוך הראייה הזאת של מה הם יכולים להפיק מדאטה אם הם משתמשים בזה נכון. הצליחו לבסס את ההחלטות שלהם על מידע, ומצבו את עצמן כחברות הכי גדולות בעולם, חברות כמו גוגל, אובר, נטפליקס, חברות שמשתמשות גם בפתרונות שלנו וגם במוצרים שהם אופן סורס, ומובילות בעצמן פרויקטים בעולמות של אופן סורס. Next slide. רוב החברות שעדיין לא עשו את השינוי הזה, באמת מתקשות לייצר ככה ערך מהכמויות הגדולות של המידע שהן אוספות. היום אנחנו מייצרים כמויות אדירות של מידע, בין אם זה דרך סנסורים או מידע שעובר באינטרנט. אם אנחנו לא יודעים לנצל את הכמויות האלו של המידע ולנתח אותם ולהפיק מהם תובנות, החברות נשארות מאחור באופן הזה. לפני שאני מעביר את הסשן לפליקס, אני רוצה ככה לשתף אתכם על הפעילות שלנו בארץ. אנחנו היום, יש לנו צוות מדהים בארץ של 10 אנשים, אנחנו עובדים עם למעלה מ-150 לקוחות בארץ, אמורים לגדול בצורה משמעותית בשנה הקרובה, מתוך באמת הבנה של החברה שישראל היא אסטרטגית ומתקדמת מאוד בתחומים של הדאטה, דאטה סיינס, דאטה warehouse, ויש פה דרישה הולכת וגדלה לתשתית שלנו. אז אני אסיים פה. I will transfer to Felix to take you through the slides of what is Databricks actually. Felix?
Awesome. Thank you very much, Lior. Since my Hebrew is not really there yet, I'm going to switch to English. And if we look at it, and we take, say, maturity in the data and AI space on the one axis and the competitive advantage in the field on the other axis, then if we look at it historically, on the left hand side, this is really about descriptive analytics. So we look in the past, we try to understand why sales went down, or why maintenance needs spiked. And if we look in towards the right hand side of this curve, then we're in the space of predictive analytics. So we think about, hey, what is going to happen? And then we take it a step further and we say, okay, this and this is most likely going to happen. So we should do this in order to address whatever happens in the future. And if we then add automation to the whole game, then this is really where there's a lot of potential in the analytics space, and obviously with AI to empower that. From a technological perspective, if we again look at the past 10 to 30 years, then the left-hand side of this curve was mainly addressed by the data warehouse. So there we would have a high reliability, low amounts of data, and high performance needs. On the right-hand side, we would have the data lake that emerged, driven by projects like Hadoop and others, where I was then all of a sudden able to store large amounts of data and do really advanced analytics and data science on top of it. But you already see the problem here, right? We have two separate technologies, we have two separate platforms, and that makes it really difficult if I have teams that want to span the whole thing across the board. So why is it difficult? And this is something where I really find myself, because say, prior to joining Databricks, I was a customer of Databricks. I started using the platform in 2018, and this thing of, hey, I take some data from the warehouse, copy it over to the data lake, and then I copy it back, and then I copy it forward again. And you do that often enough, and it becomes really difficult to reconcile where's actually my truth of data, right? Not talking about the resources that are in a way wasted in this whole copy step. So on top of having data silos, it doesn't stop there, but also we have a separate security and governance model. So I'm maintaining, and this is really what I saw in my past. We maintained really strict governance on the data warehousing side, and then we would take all of that data, copy it over the data lake. And everybody who had access to the data lake was able to see that potentially very confidential business data. And at the end, this really affects the users. So the users that you have with the data analytics a crowd, but also the data scientists and the data engineers, that ideally want to work together on use cases that span the whole spectrum across the board, but they are stuck in disjointed technologies. So here comes the catch. There is not actually a need to have two disparate platforms. If you manage to bring the reliability and the performance that you would expect from a warehouse to a data lake, with its infinite scale and economies of scale as well, and if you also manage to bring the permissioning models that you would have in a warehouse with fine-grained access control over to the data lake, then you really enable all of your users to work together, to collaborate together on one platform. And this is the Lakehouse paradigm. So the Lakehouse paradigm is an architectural paradigm that is technology independent. We at Databricks coined the term, and we have a Databricks answer to how we realize this Lakehouse platform. And if we look at it, say, from bottom to top, then Delta Lake is the technology that adds reliability and performance to the data lake, which is really good at scaling. So on top of this foundation, if you will, we then have one a security and governance layer with a Unity catalog that enables to do fine-grained permissions on all kinds of assets that you would have in a lakehouse, which is not just tables and views, but it is also ML models, for example, or it is ETL pipelines. And this altogether is what then enables the users on the lakehouse to realize different data applications that again span the whole spectrum of the data world. If there's one thing to take away from today, then that's probably this slide, because that summarizes it very well. And the three key themes, if you will, are that the Databricks Lakehouse is simple, it is multi-cloud, it runs on all three hyperscalers, and it is open. It is built on open source. We are massive contributors to open source projects, and open standards are really baked into this. And we want to enable all users of the Databricks platform to have full control over the data that they work with. And that starts from decoupling compute and storage to using open standards that are used across the industry, and that makes portability much simpler. All right, so this was now the high-level overview, setting the scene. Now let's for the technical audience, let's go one level deeper. And what you see here, I really love that diagram because it's very comprehensive. It also takes a little bit of time to digest. So we're gonna spend some time on this one. And if we go from left to right, then I think this is a pretty traditional setup for any data architecture. You have some raw data, and then on the right-hand side, you have aggregated high-quality data that adds business value, if you will. If you go from bottom to top, then we have storage, we have compute, and we have metadata / orchestration / governance. And now if we dive into it, on the left-hand side, we have different types of data. Different types of data come in different velocities, they come in different volumes, and that also come in different veracities. So you would have something from my past coming from manufacturing and IoT. We would have sensor data that comes in at high speed. So we're talking about streaming data. But we want to bring that together with the master data that sits somewhere in the ERP system that sits in relational databases. And this is something I really need to do if you want to realize this business value for it, because it doesn't really help you if you're able to predict that a machine at a customer XYZ is going to break down and needs maintenance if you don't know what their maintenance contract actually looks like, right? And the maintenance contract information, that is definitely stored in the ERP system somewhere together with all the other financial transactions. And this convergence is really one of the first steps that we need to take here. So when we talk about ingestion, and this is a cloud agnostic reference architecture. So when we talk about streaming, then you would have the native services there. It pops up, for example, on GCP, or you would have Event Hub on Azure. or you use an ingestion tool from our wide partner ecosystem. So that is now not just the native services on the three hyperscalers like say Azure Data Factory or Glue, but it is also tools like Fivetran and Archeon. And this data now flows into the Lakehouse, and this is where it starts now to get really busy. So we have on the left hand side over here the data engineers, where the different features that you have there are centered around Apache Spark as an open source technology. Then you have the data science and ML engineer crowd working and developing the ML artifacts, the ML models in an iterative fashion using MLflow, which again is an open source standard, enhanced by a couple of performance and convenience features in the Databricks platform. And now we come to the point where we want to make these artifacts available to users on the right-hand side of our data architecture. So in the serving layer, you will see that there are different methods or techniques available for serving models, whether that's now in a batch or in a online real-time fashion. And the same also applies to the data warehousing capability, where then the data analyst can hook up the Databricks Lakehouse platform with their favorite BI tool and fire SQL statements whilst getting the performance that you would expect from a traditional warehouse on top of the scale that a data lake really provides. One more super interesting, super relevant capability here on the right-hand side is the ability to share data. And now I'm talking not just about sharing some data behind a REST API or some JDBC, ODBC connection, but I'm also talking about large amounts of data. Think about raw data potentially that in a data economy, a data producer would provide to a recipient. And this can now be inside of a company that says we want to organize ourselves in a data mesh and we have different data products. But this can also be in the wider context of like between companies. So I'm company A, I have a great data product and I share it with you and you pay me for that. The real game changer here is that with Delta sharing, you do not need to copy data from one object storage to another object storage anymore, but you keep it where the data is. So it doesn't go out of sync. And instead you have Delta sharing as an agent in between that makes sure that every recipient is only able to see the kind of data that they are allowed to. And this is the perfect segue into the top here of the Lakehouse diagram, where we talk about data governance. So Unity Catalog is really the capability on the Databricks Lakehouse that enables fine-grained access control across all assets that you would have inside of a Lakehouse. And last but not least, so we at Databricks, we have a bit of experience, I would say, when it comes to provisioning, scaling up and down virtual machines. We do that around 12 to 13 million times per day. So we know a thing about orchestration and Databricks workflows together with CI/CD and the MLOps stacks. Is this last, say it's a cornerstone that then holds the whole platform together and makes its operation performant and reliable. Awesome. So this was a quick walkthrough from the left to the right of reference architecture on the Databricks Lakehouse. This could be on any cloud provider. And this is a home for all data personas, the data analyst, the data scientist, the data engineer, the ML engineer, the analytics engineer, and more on that in just a second, because this is now in the greater context of the modern data stack, where Databricks really thrives. And So we're at Databricks. I think there's a couple of things that we're really good at, but there's other things where we think that others are better. And instead of like building a wall around like, hey, this is kind of like, this is my lawn, this is my garden, you shouldn't get inside of my court. We want to be open, and we are open, have a rich ecosystem, both on a technology side, but also on an implementation side with consulting and system integrator partners. And this is something where now the Lakehouse really comes to life, and you're able to easily integrate with other technologies and reach out to a wide ecosystem of partners that have experience with implementing projects on Databricks. Again, this is available on all three hyperscalers. We partner closely with Microsoft, with Amazon Web Services, and with Google Cloud. And when we now talk about, say, building a lakehouse, for us, or in our vision, it doesn't stop with providing some technology. It's not about taking technology and throwing it over the fence or making it easily accessible in a platform or a software as a service offering. It's the whole deal around success. And that starts with solution accelerators, which is ready-made examples for, if you say, for example, digital twin in the IoT space, or credit card fraud in the financial services space, that is available on the website. You can just download the notebooks, the material, and get started quickly. This continues with both virtual self-paced e-learnings, but also in-person training offerings, and a co-located professional services team that really helps with the tricky cases, with getting started and realizing this overarching success. Obviously, there is global support, production operations at scale, 24/7 throughout the entire year, but I think that goes without saying. And I want to close with Databricks Lakehouse supports enterprises in pretty much every industry. You see a couple of examples here on the slide, but there's many more. It's thousands of customers using the Databricks platform today. I personally rather in the manufacturing and logistics space, but I also work with software companies. And yeah, I'm super excited having had the chance to speak in front of you today. We do have a little bit of time left, so if there are questions, and I saw that there were some popping up on the Q&A, we can answer them. So I don't know, Lior, had you been monitoring? Is there some that you think we should maybe read out for the whole crowd?
Yes. Do you have access to the Q&A?
Yeah. All right. So there's one that I see here from Michael, and the question is that whether Databricks can replace interactive queries of business models such as SaaS. Yes, this is basically if we go back here in the slides. This is this box. So the warehousing capability on Databricks is like a traditional warehouse, just on top of a data lake. You can fire your SQL commands, you can build your star schema models, you can also build a data vault if you prefer. And you can hook it up with your favorite BI tool, whether that's now Power BI, Tableau, preset, something else. There's many connectors available. And one thing that I find particularly interesting, having been in enterprise architecture before, is a data access REST API that's coming now. So if you think about API/data-driven enterprise, this is a crucial capability. I hope this answered your question. If it didn't, then just ping again.
I just want
Oh
to
yeah,
add, Felix, that really, since I joined the Databricks, I was really surprised to see how many companies are using this data warehouse capability that was developed at Databricks over the last 2 years, and really make use of our platform to perform data warehouse type of workloads, which is a great capability that was added over the last 2 years into Databricks.
yeah. Same for me. Again, I started using the platform in 2018, and it's a lot different than what it was back then. On the next question with low code, I think that's a super interesting and relevant one as well. So on the one hand side, if we go back here, you do have Delta Live tables, which is a declarative paradigm towards, or declarative approach towards ETL. But there's also the partner ecosystem. And for example, if you probably already know DBT Labs, and you probably also know Azure Data Factory. But one thing that I would really encourage you to check out is Prophecy. Those guys are building some really cool low code, no code tool that makes it easy for maybe not so data engineering savvy data personas to build their ETL pipelines. So I think, yeah, we still have 3 minutes. So I'm just going to go through a couple more questions. So when it comes to the semantic layer, this is built inside of the Databricks SQL warehouse. Well, this is like I said before. I mean, you can build, you can model to the standard that or to the paradigm that fits your need best, whether that is star schema, whether that is data vault, or whether that is something else. There's a couple of really good blog posts detailing how each can work. Yeah, well, training and enablement is crucial. So yes, they're on the Databricks Academy. If you just put Databricks and Learn or Databricks Academy, you'll find it. There are several self-paced e-learnings for different data personas. So there's one for the data engineer, one for the ML engineer or for a data scientist, and also one for the data analyst. So there you will find tons of material, both webinars, you will find examples, and you will also find code snippets and hands-on labs. In addition to that, there are training sessions, there are enablement sessions that are going on, where Databricks actually facilitates a training, for example, on data engineering, with I think the last one that I supported was like 2,000 participants, which was great because you have a really busy and interactive environment there. All right, I think maybe 1 or 2 more questions. Yeah, so regarding the S3 bucket, you can use the object storage of any of the 3 hyperscalers. So that would be S3 on AWS, Azure Data Lake on Azure, and Google Cloud Storage. So this is really where the foundation of the Databricks Lakehouse platform sits. And for the remaining questions, I would just stay on for a little bit more and type my questions, my answers in the Q&A directly. And well, with that, thank you very much for joining us today. It was awesome to speak to you, and we wish you a great event with many more interesting presentations.
תודה רבה לכולם, אתם יכולים להגיע אליי גם דרך לינקדאין, או ליאור@databricks.com.